All right. Hi, everyone. We are Alex and Jiska, and we are going to talk about the new satellite communication on the iPhone 14, which is codenamed Stewie. We don't know really why, but probably everything is named after like some TV series at Apple. And there's, well, only one that where Maggie runs into a satellite dish, but who knows? Maybe that's what they named it after. And with this, I'm handing over to Alex.
Okay, so why did Apple integrate this feature into the iPhone? The main reason they are advertising for is, let's imagine you're off the grid. There can be a lot of reasons for that. You can be hiking somewhere in the mountains. There's an emergency. There could be wildfires. That destroy the cellular towers. And the only way to connect to any emergency services is by using the satellite connection of your iPhone. The satellite connection allows you to basically go through a set of simple questions to state what your emergency is, and then that is sent off to a satellite and furthermore dispatched to emergency services. And then you can continue on contact with them by using text message-based communication, so they can also reach back to you. But the first thing is going through these simple set of questions. Another feature they have advertised is the Find My integration. So whenever you're off the grid, but you want to show your friends and tell your friends that you're safe and good, you can just share your location. You can update your location over the satellite. Where it's pretty simple. It's in the Find My app. You just click Send My Location over satellite. Then you search for the satellite, and your location is sent. There's also a demo mode that's implemented that allows you to train how to use satellite communication in the case of emergency. So it might be helpful for you to train that before, but it will never send any data. It's just finding the next satellite and kind of connecting to it, but there is no data exchanged. But you can use also the interface of messaging to see how that is. It all started in the US and in Canada, and we expected that this feature would take a while to roll out worldwide. But pretty quickly, they already had a couple of European countries added, and then now they added even more. So now there's a bunch of countries where you can get this feature running, and it's all based on this satellite network of GlobalStar. So GlobalStar is a company that is doing satellites since a long time, and they have a vast satellite network around the Earth, and Apple has invested into GlobalStar to be able to use their satellites for their feature. So how do satellites work? It's pretty simple, these ones at least. So you have a bunch of satellites that are flying around our Earth, and they fly around, so they rotate. They are not always at the same position because they are not at the highest orbit. That allows them to get data easier. Then whenever they are going to connect to the Earth, there is something called ground stations, so they can connect to a ground station, send a message there, and receive something from a ground station. So this network they have there has at minimum 28 satellites. That is at least what's stated on Wikipedia, and the GlobalStar doesn't state how many satellites are active. But in iOS we can see theoretically it should be more. They have an orbit of 1,400 kilometers, 870 miles. They have 24 ground stations that are also now co-operated by Apple. And they not only provide the iPhone service, GlobalStar also offers phones, which are supported, but you can no longer buy satellite-based phones from them. They have a satellite messenger, which allows you to send SMS and emails just over the satellite connection. They offer IoT chips to connect your devices that are very far off the grid, but you need to have some connection there. And now one of the main things is that they support the iPhones. So the basis of this communication is that the iPhone is sending a message to a satellite, and that satellite is sending a message back to the ground station. The principle behind that is called the bent pipe. So bent pipe satellites are like you can imagine a pipe that is bent, so the message that's coming in is just being reflected to Earth. They also call it like mirrors in the space. And the cool thing here is that the satellite doesn't need to decode anything. So if there is a decoding bug, it's not a problem because all the messages coming from an iPhone, they just upscale to a different frequency and then send downwards to Earth. So that also allows Apple to use a different communication scheme, for example, that might be more secure. So when you send a message, it goes up to the satellite, going through the band pipe down to a ground station. You're sharing your location. So ground station has access to the internet, shares that location with Apple. Apple just knows it. That location is then forwarded to your friend looking for you, and they can watch it. And internally, satellites are called targets, and ground stations are called anchors. And now Jiska will tell you all about how we did reverse engineering here, and it's kind of complicated.
Yeah. So reverse engineering options. So I'm asking the question in the room, like, when is there finally like a public iPhone 14, iOS 16 jailbreak? Well, but we can still do a couple of things, right? So we could just sit down there and, stare on the logs and stare on the binaries and figure out some things. It's not just that, like, we can do a bit more. There is so-called baseband debug profiles that you can install onto an iPhone. And the satellite feature is part of the Qualcomm modem. So it's the baseband chip doing also your day-to-day 5G, 4G cellular communication. When you install such a profile, then in your syslog you would actually like see, okay, difficult to see, but like here marked in blue, you would see the packets. So it's the raw packets sent to the baseband chip or commands that you could then analyze. Now this still looks very, very cryptic, but luckily I had a very skilled bachelor student and he built a tool to decode those packets and automatically, so he looks through some iOS libraries and automatically generates a Wireshark dissector that creates human-readable output, including names of some of those packets. And with this, we can get an idea of how the communication works in detail. So what we see first is some file transfer, but that file transfer is basically like the targets, so a configuration of the satellites, like where they are, so that your phone knows what to do, and also the device orientation. So when you move your phone, the baseband chip knows how your phone is oriented and where the satellites are. No, I think I need to move a bit so that you can see everything. Sorry. Right. And then afterwards, there's some stuff only taking place when you do Find My, not in this demo tryout mode. So if you are sending a Find My location, then there is an activation step with the satellite and also a security configuration, which contains some public encryption key that Alex is going to talk about later. And also, in the end, there is going to be an encrypted message that we send. So we give that message to the baseband, and afterwards the baseband updates us about the transmission state. So you have this progress bar, and that's basically send in between, and like if you change the device orientation, that's also updated. And finally, if the satellite confirms the reception of our message, we get an indication of the message transmit status. And at least in the case of Find My, where we only send one location, afterwards the satellite communication is deactivated. All right, so with this, we already have some idea like of what is happening, but it's super low level, and it would be cool to, dig a bit deeper into the system. There is one thing that we can do on an iPhone 14 up to iOS 16.1.2, which already supports the first countries, which is called Kawabanga. Like, that's not a full jailbreak, but you can replace files on the file system that are not code signed and that are only in some file paths, but it's enough to tweak some stuff like making more enhanced logging. Even if there is no debug profile, you can also attempt to back up more data. And it has another feature like over XPC you can send some message that crashes daemons, and in our case, we want to crash the comm center daemon, which is like the daemon responsible for baseband and satellite communication, such that we can, for example, observe the chip initialization. Then there's another option, which is Corellium. I know like they don't have a physical modem in the phone, but the phone still would think it has some satellite features. You know, the software with the satellite features is on it, the configuration with that features is on it, and actually that means when CommCenter boots up, it would think, oh, I have a Stewie service, like I cannot really talk to it and everything is kind of null, but you know, like it must be there. I think Stewie will be there at some point. And it has very easy dynamic instrumentation, so there's Frida on it and everything, and it just, you know, it really works well. And luckily, we also got a security research device by Apple, but this is an iPhone 13 mini. You always get the model from the year before. So the modem does not actually support satellite, but the binaries that are required to have some of this satellite communication, they are still on the phone. So, well, can we maybe make it think it has satellite? That would be awesome for reversing. Now, to understand what we even want to reverse engineer, here's a brief overview of the internal components. So, if you have satellite, then you will have in your settings a tryout mode, the demo mode, and when you click on that, there is an XPC message being sent to CommCenter, and CommCenter says, okay, I'm going to activate Stewie now with the reason number 5, which is emergency tryout. And then CommCenter launches an app called SOS Buddy, and this app, SOS Buddy, is actually launched by a URL, and it gets this parameter, reason is offer emergency tryout. That looks pretty reasonable, and while they are in this tryout mode, they would also send forth and back some information. So basically, you know, the UI would tell CommCenter like, hey, there's an update on the device orientation, whereas CommCenter says like, okay, now I got like a satellite signal, or I got a location, or whatever. Find My works kind of similar. So you have once, at least like once you have no Wi-Fi connectivity, but Wi-Fi is on, and you don't have cellular connectivity, but a SIM card, which, you know, you just take the SIM card from whenever you were traveling the last time. Then you can get this button to click, and then you say, okay, I want to send my location via satellite. And next thing is, CommCenter is then again going to open that URL and tell the SOS Buddy, hey, here, reason is Find My, please, you know, start that in SOS Buddy. And that's this step. So here we just, you know, we have this whole user interface. So that sounds pretty reasonable, right? We have this launch URLs, and they will, you know, do something with CommCenter and the SOS Buddy. And there's one more thing, like overall CommCenter then keeps updating certain components in the system. Like CommCenter will tell Find My via search by DD, hey, your location was sent, or something like that. So CommCenter is the central part of that satellite communication. And there's one more thing. So while there's things going on in the background, you can actually close the app, but you will see that nice pizza icon in the top, you see? And I think maybe Apple just ran out of wireless symbols and then decided like salami pizza looks like, yeah, I don't know. All right. So my first thought was, hey, we have Cowabunga, so we can get logs, and I can just, you know, build a regular app. So I tried my best to, you know, build an app instead of breaking an app. And try to open URLs directly. I reverse engineered this list of reasons in the URL, and I was really happy. I was like, okay, this is it. I can just, you know, open URLs, try making an emergency call or whatsoever, and that's it. But, you know, No. Actually, only works for emergency tryout. That's the only thing that works. Everything else heavily depends on the interaction with other daemons and comm center initializing this properly. So what can we do? Well, maybe, we have to send something to comm center on a device with a jailbreak, but yeah, so we use Frida. Frida is really my favorite tool for reverse engineering, and we modify that XPC message being sent to comm center. And then we can use the launch URL to really open a real kind of emergency case. So we are no longer in emergency tryout, but we are in the emergency text mode where we can send like these messages and the reason like with this dialogue that Alex briefly showed to you. Now, to achieve this, we have to fake a couple of things, right? So we really fake it till we make it on the security research device because, iPhone 13 minutes, like almost an iPhone 14. You just need to tell it for long enough. You're an iPhone 14, you have a satellite modem. So I really just wanted both in one phone. And I tried really hard. And first thing I did is, look into Corellium because I have an iPhone 14 there that's jailbroken. And during the initialization, there is a very critical part that is called GSM radio personality create. GSM radio personality defines what features are available in that modem. Like, does it have satellite or not? That's the really critical part for us. And if you look into this, it's written in C++. You can see all those parameters here. It basically gets the phone model, a hardware config, but the hardware config is just a number, and also the board version. Those values is something that it gets from something that's called libmobile gestalt, and that's just a plist with somewhat obfuscated keys, but the values are not obfuscated, so only the key entries are hash summed over something so that you cannot that easily modify it because it's something jailbreakers love to do. Like if you modify libmobile gestalt, you can modify a couple of features on the phone, so Apple put some effort into obfuscating it. And from this library, we get the values that we have the hardware configuration, hex 34, a model IP, and we are like a real iPhone 14. Then there is a second thing. So if we make it into this switch case, like it's a really, really long switch case that I didn't print there, which initializes the whole personality with every single sub-feature that the modem supports. But then there's this switch case where it says, hey, does comm center have bfrost enabled? Whatever that is, yeah. And then there is a libsystem feature flag dilib where you would get this from. Now it's really confusing because I also hooked cfprefd. I thought it's getting a preference, but it's actually all coming from these two plists that make the phone think, yes, I have satellite. So yeah, what do? We do the same on the security research device now. And on the security research device, if we apply this, my first idea was, I just rewrite that property list. So the property list that tells it you have hardware model hex 34. Just replace the number. But this actually goes wrong because then the whole baseband or the whole comm center thinks, okay, we now have an iPhone 14 baseband. So it tries to load the iPhone 14 firmware, but cannot find it on the path, and a lot of weird things happen. So it's not as easy as modifying a plist. So next thing I did was to just hook that function with Frida. So I just replaced the hardware config number, and that's all. And the rest is, kept intact. And this turned out to be working for me. So now the modem thinks, yes, we are there. The second file, so that's the hook here, just for completeness. Now the second file that I was talking about is this other plist that holds the feature flags, but on an iPhone 13 mini, the bfrost feature flag is already set. So That's pretty good. Now, after this, even like whatever we do, there is a request always sent, which is, is Stewie actually enabled? And we need to put another Frida hook there saying, yes, 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 we have Stewie enabled, like whenever we are asked if or if not. Then there is another obstacle, which is, comm center, when you don't have Wi-Fi or cellular connection, is actually setting a so-called service mask that's saying like which services are currently enabled. And the service mask just is like a hex representation or like a bit mask representation of all the features that are available that we saw previously also in this URL reason scheme, so that we can, say like can we do find my or not, and so on. Now, this is all stored in a struct somewhere in comm center, and I found a good position to hook that as well, just to say, yes, all features, we just set the flag to F, everything is enabled, and just like get another small hook to say, yes, the service you just requested, yes, yeah, it's all enabled, it's all fine, let's go for this. Even with all those hooks, we can call URLs, but it doesn't yet show up in the UI. But once we manually called the URL with this little script, everything kind of, sets up. Probably just the scripts are actually executed that I put there for the first time and are setting some values. So suddenly, when doing this afterwards, you would finally have this button appear in both Find My as well as the preferences. Now there's even more going on, like for example, the location daemon has to send a location to the comm center, and this location must not be a Wi-Fi source, but it must be a GPS source, and it must not come from the simulator. And if this succeeds, then the SOS body is updated like, yes, we got like a good GPS location. And this is yet another hook to write, and then we're almost done hooking. We actually see now finally comm center trying to talk this QMI protocol. Now, not everything of that QMI protocol is implemented in the baseband chip because it doesn't have Stewie. But that's the smallest problem. We have that in the Wireshark log, so we just hook the other functions for sending and receiving QMI. And now that's it. The boring part is over. We are there. Yes. So yay, we can finally send, emergency calls on an iPhone 13 mini without causing an emergency. We can try all the features and there is nobody going to rescue us, which is really, really good. So, I'm at my home hacking, please rescue me. Great. Now, that was a lot of hooking, and you might be asking, like, why did you even do that? Well, there's a couple of things why it's good to have that. So Stewie is this satellite feature in the modem. We had Bifrost as well, and there's actually a word Bifrost with an Ö. Probably, I as a German can pronounce that. I'm not even sure if in the language where it comes from it's pronounced like that. But Bifrost is like the communication, or not communication, like the bridge between Earth and heaven over a rainbow. And that's what they named it after. So it's pretty good as well. Now, once we have all of this set, like, what happens on a device when Stewie is actually available? And there's a couple of things that we can now look into, and we can grab files that are really difficult to get from a non-jailbroken device and get a lot of details and internals. The first one is, comm center has an entitlement for trial D, or for trial, and the trial daemon is a daemon that downloads certain configurations or features from Apple, so that even like without a system update, they could enable or disable certain features and send you certain assets. So we are now at trial declined, and we get 2 files from this, which is a target plist. So target, you remember, like the satellites, and also another one that's called config plist. And these are now just, being sent back. And finally, yeah, we can just look into those things. Now, this is the targets. That's pretty interesting. So a colleague of us digged into this a bit. The target plist has a 2-line format like this. You are not supposed to read this in the back, but basically, this is the plist out there. And with this plist, there's like 2-line elements in the standard SGP4 format used for satellite positions. So we can figure out the satellites that are out there, and from the configuration sent over QMI, we extracted that first, so we didn't have the plist back then. And we could figure out, the red dots are the satellites that they used back in April this year, whereas the black ones are those that are probably overall in use by GlobalStar. So you can kind of compare this and get an idea of like where the satellites are, which satellites are being used. Now the config plist is also quite interesting because it tells you in which countries this is active and also which frequencies are being used. But the frequencies are there in the form of channel numbers. Now there's one last interesting entitlement which is there for mobile assets. So the mobile asset daemon is actually downloading a so-called codec. A codec could be in English or in German or something. I guess the codecs are also the reason why the rollout is so slow. So this is a codec. A codec is just, some hex format. I haven't understood it in detail yet, but it is like, for language compression to English or German or whatever language. And that seems to be pretty complex to achieve. And that's really a good feature for your text messaging after you made it through this select your emergency case. And with this, I'm handing over to Alex.
Okay, so now I will tell you all about how the satellite communication is actually secured. So for any kind of communication, it's good to have some keys. Apple calls them the LLC keys, and these LLC keys, they are generated on your phone. So when you generate these keys, they are actually not generated just on your phone, they are only generated in your secure enclave processor. So that also ensures it's always NIST P256 elliptic curve keys, and they are also only stored in your secure enclave, so these keys can never leave your device. But you can export a public key. If you want to reproduce how these keys are made, you can use this little Swift script I made here, which is exactly the code that Apple executes to create such a key. So, but now you have keys on your phone, or you can use them to theoretically encrypt data you send, but how does Apple know that data is actually coming from you and that this data is supposed to be used for satellite communication? So what you do before you can use any satellite communication, your phone starts communicating with the Apple server and sends all the public keys to Apple. So Apple then has all the public keys and generates its own server public keys for you, for every one of your keys. So every key of you gets its own Apple key, and they are sent back to you. And then they are saved in the keychain, and then you have two types of keys. You have your own private keys in your secure enclave processor, and you have Apple's public keys. The cool thing about the secure enclave is that you can use cryptographic operations, like you can perform key exchanges. So if you use that with the public key, you can generate a shared secret. And that's what Apple is doing here. So for every communication, you have one key, and that's being used with the satellite interface. And after you have used that key, it's thrown away. But there will always be one key that is marked as last resort on your phone, and this last resort key can probably be used multiple times. So far, we only realized that when the phone is offline for too long, and you have done a bunch of satellite communications, it will stop working. But it can also be because of your phone doesn't know where the satellites are at the moment, because these plist files that Jiska has introduced, they have to be updated regularly. So we will, in this talk, just go into the Find My location sharing because we didn't go too much into the emergency services, just not to cause any disruptions. So this Find My location sharing is quite interesting, just first to know how it works in general. When you have internet connection, it basically just works like that. So when you want to view someone's location, it's not updated always at just automatically. The person of which you want to view the location gets a push notification from Apple. And that push notification triggers that the phone updates its location, and depending on which kind of location you want to view live or just one update, it starts sending location updates to Apple until you desubscribe from it. And these location updates are then sent back as push notifications, so you can view where someone is just walking as you try to find them or something. So in the end, you have the location, and you can see where the person is. Cool thing here, Apple is using end-to-end encryption. So every time you are sharing locations with friends, Apple is not knowing where those friends are, where you are. It's all end-to-end encrypted. And that is based on a key for sharing location with friends, something like that. Yeah. This key is known by both of the friends, and it uses so-called ECIS encryption. I don't go into too much detail on this one because I know after lunch Christine will tell you all about ECIS encryption. And with that ECIS encryption, you get an encrypted location. So this is the one. There's this is the call you can use in iOS if you want to reproduce it. So then the server communication is quite simple. You can see that when I want to view a location, I'm not asking I want to view the location of that email address or that person. I just send like some Find My ID and a location ID to Apple, and Apple server looks up if there is the current location and sends it back to me. That current location is then this huge encrypted blob because it's having like all this like location details, like accuracy, has like elevation, bearing, everything that's in the normal Apple location object. So what happens if you do it over satellite? So we know how it works when you have a connection, but it works a bit differently when you're sharing location over satellite, but it's very similar. So you start by using Find My, but you have to actively share your location because there is no way how someone can send a push notification to you, because then your phone would have to have a satellite connection all the time. So you go to Find My, you hit the button, and then Find My tells Comm Center to launch this SOS buddy. That's what Jiska just told you all about. But there are a couple of more daemons involved that are handling a location and encrypting and everything here. So there, first and foremost, there's the Find My device daemon. That daemon will talk to the Find My app and make sure that they are in sync and you know you're sharing the location to the right people and so on. So then you have the location daemon that actually fetches the location. It sends this location to Comm Center and the Find My device daemon. So Comm Center needs the location to know where you direct your phone to for the satellite, and Find My device needs your location to actually send it. Then this Find My device daemon talks to the search party daemon, and that search party daemon gets a location, and then the search party daemon knows your keys for sharing with friends and creates an encrypted location and sends it back to the Comm Center. So you have like a loop of location exchange, and Comm Center in the end knows your encrypted location. So what does it do with it? It just wraps it into this Stewie Find My message, and that is then wrapped into a Stewie transport message, and then this data is shared with the baseband. So Comm Center basically sets off your location to the baseband, and now the baseband is doing all this satellite uploading and communication with the satellite. Interesting here, Apple wants to save data, so they have these models for communicating in an emergency case and compressing language, but they also try to compress the location data, so they use something called light location. The light location is just a kind of stripped location format. It takes your floating point values for latitude and longitude, makes some fixed pointer arithmetic to create two integer values, then also adds the horizontal accuracy, and in the end you just have 9 bytes of data you need to share. So this will then just basically look like this. You have and then you have like large integer numbers. So it's a very simple format, but it compresses the data as best as they could. So this format is exactly the same as it used for AirTags. So whenever your phone finds an AirTag, it does exactly the same thing to not load huge amounts of data into Apple's database, because to find an AirTag, you just need latitude and longitude. And so we know that from this part as well. The actual satellite transmission then is the same. You get your encrypted data with ECIS encryption, and this is uploaded to the satellite. So we asked ourselves, how could this be misused? Because, you know, satellite communication is kind of expensive. Apple has bought like a lot of bandwidth from GlobalStar, but if now all of our iPhones would start to communicate with the same satellite at the same time, it's not working. They have like a maximum bandwidth of just 9,600 bits per second. So it's not really a thing you can just use all the time. So that's why they limit the location sharing feature, that you can do it only every 15 minutes, and there is currently no other features on top of it. If there will be more satellites, maybe we can use it for messaging or something like that, but currently that's not possible. So we thought about, can we manipulate the location to send messages instead of location data? So if you have the Earth, you know that the latitude and longitude values, they have a kind of range they are in. So if I change that latitude, longitude values to specific numbers, I could maybe send data. So I would have 8 bytes of data that I can send instead of latitude, longitude values. So to make that very simple, you can think about mapping the alphabet with lowercase and uppercase letters and some numbers to just a fixed number. Then you have a 10-digit space you can use, and then you use 2 digits for 1 character, so you would have like 5 characters per coordinate, and in the end you have then 10 characters. So you could send hello world over the satellite feature of the iPhone, but the problem is that Apple was a bit smarter than us. So the idea was, we have an iPhone 14, so we cannot modify the location data directly, but there are like features for developers to modify where you currently are, and I know that Apple knows when you're using them, and supposedly my idea was, I change the location data, and Comm Center knows my actual location, and then the satellite feature will just work fine, but the search party daemon might get a different location that is faked and just takes it, and I can send the data. The problem here was that there is a check, so also Comm Center checks if your location has been changed manually, and so it doesn't really work. You can just still connect to the satellite, and you think it works, but then it will never send a message, and basically Apple just blocks you from using satellite communication for some time, so I couldn't also use it for some days afterwards. Yeah, so we are still back, and this question?
Yes, so when is there finally an iPhone 14 jailbreak? So yeah, begging you for this, so that we can do research on an actual modem. Anyway, that's it with our talk. If you have questions, you can contact me via this email address. I just started a new research group, so if you want to do a PhD on iOS security, you can also talk to me. And of course, you can also ask questions to Alex.
Yes, and if you have questions now, I don't know if we have some minutes. It looks pretty tight.
Yeah.